All right, you guys. I'll share my screen real quick to show you where to find the videos because I got a few emails saying they couldn't see where the video was. Now there's two spots, right? If we're having a live lecture, you go here, go to recordings, and you'll see here. But if I'm disconnected for whatever reason or I upload a video for you, right? You're gonna go to lecture notes and click on the chapter that we're covering, and that's where you see the notes. So for chapter 3, those 3 sections, here is the video. It's a YouTube link. So just click on it, upload it up in a new page, and you'll see the video. For chapter 5, here is 5.1 and the lecture for that one. Yes, oops, let me see. I have no audio or video, just a frozen screen. Ooh. Is everybody having the same issue? Because there's 2 possibilities for that. Either Kate is disconnected or I'm disconnected, and I think it's just him. Ah. I see. It's frozen? Alright. So, let's share the cam. Does anybody have any questions about those videos or how to find them? Just go to lecture notes and you'll see it there next to the notes you need to use. But yeah, for exam 1, it's on September 24th. That is next Thursday, right? Next week, a week from today. I'm gonna keep it open all day. So it's gonna open at 12 a.m. and close at 11:59 p.m. You have all day to take it, not just during class time. So if you want to get it out of the way in the morning, you can. If you want to wait until the evening, you can. It's up to you. Just make sure you start the test at like 10:30 so that you finish before it's due, because you only have an hour and a half, right? And you have only 1 attempt. So once you start it, you have to finish it. You can't retake it. I was having trouble logging into Aleaks, but we have had... Yes, we do. We have homework every week. For the past week and like 4 sessions, I postponed the due date to make sure everybody got into Aleaks. So did you mention this problem to me before? Because I don't recall getting an email from you. But I mean, I guess you could go in and try to complete the homeworks. They're due tonight. So 1, 2, 1, 5, 1, 6, and 1, 7 are all due tonight. Everything for the past 2 weeks, I kept the due date open up until today, so everybody would get a chance to log in and complete their homework. I can't postpone it anymore. Are you still having trouble? Can you log in or not yet? Yeah? No? Sarah? I tried resetting my password, but I never got an email to it. Okay, maybe you need to try another email, or maybe you went to junk, the junk mail. Tell you what, try maybe contacting customer support. I finally understood how to use it somewhat. The Aleaks, you mean? Yeah. Okay, since you guys are still having trouble, I can postpone the homework 1 more week, but don't keep waiting, because the more you wait, the more you'll have to do in a shorter amount of time, because we are covering more sections and those are gonna be due as well. Okay? So Sarah, I suggest you contact customer support and try to resolve the issue, because I can't control what the website does, unfortunately. But yeah, who just said something? So where are the answer versions of the posted notes? I usually put them like right underneath the notes. Kate, did you say something? I thought I saw the name, but I don't see anything. But yeah, so hold on. Is today the review for exam 1? No. Your exam is on Thursday. I don't do review in class unless you have a specific question. I will upload a practice test for everybody during the weekend so that once you're done studying, you can take the test and see how you do to practice. And if there's one of the questions that you didn't understand or need help with, I'll go over it on Tuesday with you. But other than that, no. Okay, so that's 2 questions. Good. Let me both required to share screen, so let me do that. Okay, here's my screen again. Oops, here we go. All right, so chapter notes. This is where you see the notes we cover in class. And once you watch the video and we finish the lecture, I will upload the solution in here, right? So if you see for chapter 1, these are the notes we did for the previous sections. I will upload the solutions for you to make sure you have everything you need. But right now I haven't done it yet, so you can use them while you study. Just make sure not to rely on the answers too much, like try to work them out while you're watching the lectures again if you want to, while you study. That's why I have the blank copies for you. But this is where you'll find the solutions, like I will upload them here today for everything we covered so far. Now to the other question, the reviews, this is the lecture note folder. Right underneath, as you can see, exam reviews. If you click on this one, this is where I'll upload it. Now, exam reviews usually go into this folder the weekend before the exam. So that will be this weekend. Probably today or tomorrow, I will upload it here. Please don't use the exam to study. Use it to test yourself. So once you're done studying, take a test and see how you do. That way you'll know how you'll do on the actual exam. If you use it to study, it's not going to do you as much good as if you tested yourself with it. Does that make sense? But if you study my notes, because like almost everything I bring on the test covers the same concept as the notes. So if you understand everything added in the notes, you should be able to pass the exam. My exams are usually 25 to 30 questions. I don't normally get up to 25, usually, 30. It's usually 25, 26, maybe 27, but yeah, no more than that. It's going to be online, and to take it, you're going to need to use a browser called Lockdown Browser. And as you can see from the name, it's a browser that locks down everything you do. So once you start the test, it won't allow you to do anything else. You won't be able to look at other pages or do Google searches or anything, but take a test. And it's a browser just like Firefox or Google Chrome. You download it to your computer, and you log into Blackboard through that browser, and you take a test. So if you use another browser to take a test, you won't be able to access the exam. You have to use Lockdown Browser. So far, so good? Any questions about the test? Okay, I'll take that as a no. Now, on your exam, how to use your notes, you can use a calculator. Are you going to post a link to it, to the browser? Yes, I'll post an announcement that explains what it is and how to download it. All right, so keep an eye out for that. So when you're taking a test, you are allowed to use a calculator, but you're not allowed to use your notes. Okay. Now the calculator must not be a graphing calculator. Well, I'm not writing anything, so it's fine. Can you hear me at least? Look, is my voice lagging? Yes, no, maybe. Not for me. Okay. What? Connection good. Okay. All right, good. What was I gonna say? Oh yes. You're not gonna use a graphing calculator, just a normal calculator, no graphing. However, if you are gonna buy a calculator, might as well use the one we're gonna need, or buy the one we're gonna need later on. So as you can see, this one, I recommend this one, but you can buy any calculator that has this button right here, the one I'm pointing to. It's a button that does log to a specific base, just to get closer. Oops. See that? Log to a specific base. But says connection is good. I think he's the only one having that issue. Try. We'll see if he can connect if he logs out and in again. Yeah. So if you're gonna buy a calculator, might as well buy the one we need. The reason we need this button right here is because we're gonna do logs to different bases. That's gonna be later on, like maybe chapter, I think it's 9. I think chapter 9. So it's gonna be content for exam 3, way like 2 months from now. But might as well buy the one you're gonna use, right? Now this thing is not expensive. It's like 15 bucks, and you can buy it on Amazon or Walmart. It's a Casio FX991ES Plus. It doesn't have to be this one specifically. Just make sure you have this button right here. Normal calculators have these two buttons, which is the log and the natural log. Almost every calculator has them, but not everyone has this one. All right? Log to different base. You see the difference between the log button and that one? Has 2 squares next to it. But yeah, that's the one you're gonna use. Okay. One more thing I wanted to go over today is the homework. It's because a lot of you did your homework, which is awesome, but a few didn't, and I can see that a few didn't enter the website. Well, now I know some of you are having issues, so please look into that and try to make sure you cover, you get the issue fixed and try to do your homework as soon as possible. Let me know how it goes. Like tomorrow, if the issue wasn't resolved when you contact them, let me know, and we'll see what we can do about that. Maybe I'll contact the department or something. I don't know. But yeah, but I wanted to go over the homework percentage with everybody to show you how important it is, because usually students tend to neglect their homework and then realize it's important, but it will be too late. So homework is usually 30% of your grade in math classes. So that means that the other exams are the 70. That means if you get 100 in every single test, you'll barely pass the class with a C if you don't do your homework. See how big that is? This 30% is bigger than the final percentage, which is 25. This is the 30% that's supposed to be in your pocket, because you can do your homework over and over until you get the questions right. And once you do, you're guaranteed those points. All right? So please try to do it. Now, I'm not sure if ALEKS allows you to do to submit homeworks past the due date. I set it up to be that case before the semester started, but one of the instructors brought to attention of the department that the website resets the settings repeatedly. So I'm not sure if it removed that option or not. So I'll look in on that this weekend. I hope it didn't, because that gives you the option to submit homework past the due date with a penalty. But you know, a penalty is better than 0. The penalty is 20%, so getting 80 out of 100 is better than nothing. But we'll see. So at this point, I'm not sure if you can do it past the due date or not. I'm looking into that. Honestly, this website is bad. I don't like the book, and I don't like the homework platform they're using. But what can you do? The department picks it. Like last semester, we had Connect Math, which was a lot better. So we'll see. I know you're having trouble, but nothing you can do about it. Like even the homework questions is set up by the department, not by me. So, anywho. So let's get started. Today we're going to talk about functions. Does everybody have the exam information down? Yeah? Kate, were you able to get back in? Let's see here. Looks like it. Can you hear me? Okay. I don't think he can. Okay. Well, it goes. All right. So I guess you can watch the beginning of the recording since I started recording with the instruction. Anywho. All right. So here we go. So the first part, we're going to talk about the definition of a function and what it is. So a function would be a relation between x and y, right? Where we are seeing the connection between certain x values and y values. And in those connections, we usually have a relation where x is considered the independent variable and y as a dependent variable. Now, what do I mean by this? I mean that you're going to have what looks like an equation or an equality relation between y and x. And you're going to have y in terms of x. Now, when you're dealing with a function, you're going to deal with a range of values for both x and y. So the range of x values is called the domain, right? So this is your x values. And the range is your y values. Now let's define the function, see what it actually means. Here's a definition of a relation that needs to be a function. So given a relation between x and y, right? So given a relation between x and y, we say that y is a function of x. Yeah, so we say that y is a function of x for each x value in the domain there is a y value in the range. Now, let's translate. What does that mean? That means that in the range of functions that you're going to have, for the x values is called domain, for the y values is called range, we're going to have a relation that we defined as y is a function of x if for each value of x that you have in the domain, there is a y value. That means only one corresponding y value in the range. So each x in the domain has to be every single one. Each x in the domain is connected to only one y value in the range. Let me give you an example. This is number 1 in the notes. This is a set of points, right? So we're defining this as a relation, and I want you to tell me if it's a function or not. We have the point 2 and 3. Now when it comes to ordered pairs, you know this is the x and this is the y. Yeah, this was in the previous section. So 2, 3, and then you have 2, 4, and then 3, 5. Okay, x, y, x, y. Now, over here it said that for each x we have a y, and each x we see we do have a y. That's true. However, notice that the first 2 points, yeah, have the same x value, but they have different y values. So that tells me that the point x equals 2 for x has two corresponding y values, not one, right? It's two. So this is not a function. It has to be only one. Did everyone follow that? Anyone has any questions? I need to make sure before I move on, because we're going to use the concept of a function all throughout the semester. So you need to have this down. Okay. Oh, and Kate, make sure you watch the recording, because at the beginning I talked about the exam and a few details you need to know, but it was recorded, so if you watch the first few minutes, you'll be good. Okay. Now, awesome. Now, let's look at the second example. How about this one? Over here, we have 1, 3, 2, 3, and 3, 5. Okay. Now in this example, we have different x values for all three. 1, 2, and 3. Yeah? So I already know we don't have an issue in this one. Okay? But looking at the y values, I have the exact same y value for two different x values. Does that matter? No, because the definition specified that each x value needs to have one y value. It never mentioned that the y value needs to have only one x value. Does that make sense? So you only care about this rule in one direction, from x to y. That's it. So this is a function. The answer here is yes, that's a function. I have 1, 2, 3 x values, and they're all connected to a y value, and the x's didn't repeat. So we are good. Okay, now let's look at this one. So let's call these x and these points y. We have -2, 6, and pi. -2, 6, and pi for both. All right. Now, can you tell me if this is a function, yes or no? Oh, I didn't do the arrows yet. Okay, so I'm connecting the -2 to -2 and the 6 to pi. Is this a function? Look at the definition. For each value, one y value. Okay, if I do this, you are correct. The 2 and 6 each associate with one y value. You don't have one x value going to more than one y value. However, we do have one without a connection. That's a problem. That means this value is not in your domain, because if it is, it needs to connect to a y value. Does that make sense? So as far as the domain is concerned, if a value is to be included in your domain, it needs to be connected to a certain y value. Doesn't matter which one, just has to be connected to a y value. Otherwise, it's not in your domain. But the opposite is not true. For example, same group, -2, 6, and pi. -2, 6, and pi. Now, for this one, what if I do this? This is a function, yes or no? It's a yes. Yeah, because each x value is connected to a y value. So we're good. Now, over here, we have a y value that wasn't connected to anything, but as far as the range is concerned, it doesn't matter. You can just exclude it from the range. It's not in your range. Suppose that. So the domain defines the range. Does that make sense? Because the x is the independent variable and y is a dependent. That means y depends on what x is. So if something here doesn't fit, it's just out. What are these types of questions called? Well, this is us defining if a relation is a function or not. So we're still in the definition of a function. Right, so this is defining a relation as a function or not. Okay? So what if I asked you to do it using a graph instead of giving you a set of points like this. So I'm going to use the first page of the notes and go here. So if you printed the notes, you already can see this. If not, just look at the screen, right? Now, there's a certain test we call the vertical line test. And the explanation, yes. And the explanation is right here. So, like I said, my notes are enough for you to study. It has everything you need. So over here, vertical line test and the definition of it. But in short, you literally draw a straight line through sorry. You literally draw a straight line through the graph. And if it enters the graph at more than one point, it's not a function. So is this a function, yes or no? No, because if I do this, we have how many intersection points? 1, 2. So it's not a function. And the test only needs to fail once. So even if it works at other spots, if it fails once on the graph failed. It's not a function. Okay? Now, how does this fit into what I just said before? Well, if you look at this x value, this is 2. X equals 2, that line you're seeing. That means that at x2, y equals -1. So we have the point 2, -1. And -5. So 2, -5. So kind of like the sets I gave you at the beginning. You have the same x with 2 different y values. That's why. You can't have more than one intersection point. Okay? Now what about this one? Function, yes or no? That one is a yes. Here, 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 here. We're good. It's a function. Okay? What about that one? And let me zoom in a little bit more so you guys could see a little clearer. Can I maybe do this? Oh, that's a lot. Okay. That zoomed in more than I thought it would. Okay. So how's this? We have an issue at the point 0 for x, right? At the point 0, we have what? A point right here and a point right here. That means that at 0, y has 2 different answers, which means this is not a function. So no. But here's a question. What if this one right here was hollow, like that? Right? So I'm just regraphing this part of the graph. What if this one was hollow instead of filled in? Then it would have been a function. You see, over here, the fact that both these points are filled in, that just means that both of them are included. Do you remember when we were talking about, I think it was 1.7, we talked about the parentheses and brackets, right? 1.5 and 1.7. Not included, included. That's what these are. If it's filled in, it's included. If it's hollow, it's not included. Okay? So over here, I'm saying both points are included. That means x equals these two y values at these 2 points. That's why it's not a function. But if I hollowed out one of them, that means that x just equals one of them at that point, not the other. So if this was hollow, then at x equals 0, y is -4. Just -4, it's not -1, right? This jump only means that at the point 0.000001, just like really close to 0 but not 0, then y equals almost -1 but not quite -1. Does that make sense? Because it's going to be hollow. But since they're filled in, it's a no. If this was the case, it would have been a yes. Okay? Does anybody have any questions? Everybody get that? Straight line test and the points. All right. I take that as a yes. Okay. Now, oops. straighten this out. There you go. Okay, so now let's move on to solving a function or addressing a function. Now, usually you write out the expression of a relation like this. And like we said, this is read as y as a function of x because you have the dependent variable y equaling a relation in terms of x. So x is a deep independent one. And if you were to graph this like section 5.1, you'd have x, y, pick random values for x, plug them in here, find what y is, and then plot those points. So I want to introduce you to this notation, f of x. This equals y. So when you see f of x, I'm just saying y in a fancy way. These two are the same thing. It equals y. So this right here, this line, can be rewritten as f of x equals 2x plus 1. And when you solve this, you're solving for y. Any answer you come up with here is going to be y. Now, example number 12 in the notes says what? You have f of x equaling 2x squared minus 3x plus 1. Okay, well, since it's f of x, that means it's a function of x. That's why I have x right here. So I'm saying this is a function of what's between the parentheses, which is x. So if I ask you to find f of -3, that means I want you to plug in the -3 in here. This right here would be the exact same thing as if I gave you this relation right here, right? It's the same thing, just y instead of x. And then I told you x equals -3, find y. So what do? You grab the -3, plug it in here instead of every x, and you solve, and the answer would be y. Exactly the same thing. That's what this means. So instead of the x, I'm asking you to plug in -3. So 2 times -3, and then you square it. See, because the x was squared, I'm squaring the -3. Minus -3 times plus 1. And we solve. 2 times -3 squared is 9. So 2 times 9 is 18. -3 times -3 is positive 9, and plus the 1. Answer is 28. This is your y value. So since this is a function, if I was asking for the point or ordered pair, which looks like this, where this is the x value and this is the y value, right? Y would be the answer you just came up with, 28, because f of x is y. You are finding what y is at the point of -3. That means x is -3. Make sense? Questions? Yeah, absolutely. Just wanted to make sure you got it so far. Okay. So let's do B. How about this one? This one says f of root of 2 equals what? So on this one, I'm plugging in square root of 2. Just like A, but instead of -3, it's square root of 2. Can you do this one? I'll give you about a minute or two. Plug it into the function and give me the answer. And then we'll go over it together. Yes, that's right. Okay, now let's go over it together. Here we go. I'm plugging in root of 2 instead of every single x, right? So you have what? 2 times square root of 2 squared minus 3 times square root of 2 plus 1. All right? Now, square root of 2 being squared, what happens? The 2 cancel. The square root with the squared. So you end up with 2 times 2, which is 4. Okay. Minus 3 times square root of 2. And then plus the 1. You can add the 4 and the 1 together. That gives you a 5. If you stop here, you got it right. Because this is the simplest form you can use without actually using calculator and finding the answer in decimals. Okay? But if you wanted to continue, the answer would be about, actually I should do approximation instead of equal. It should be about 0.7573, blah, blah, blah. Yeah? But that's your answer. Okay. What about D? That one should be fun. In this one, the question said what? I want you to plug in f of 3 plus z. So not only did I give you a number, I gave you a letter. I want you to plug in a variable into a variable. And the only reason I'm showing you an example like this one is because I want you to understand that anything, and I mean anything I gave you, inside these 2 parentheses right here, f of whatever's inside, all of that replaces the x. I don't care how many things I give you. As long as within these 2 parentheses, they replace every single x you have. So that means it's 2 times. Now, you don't give me 3 one time, z the other time. You give me both. 3 plus z squared. All of it. Minus 3 times. Again, 3 plus z. And then plus the 1. Okay? Now let's solve it. So, over here we have what? We have a pair of parentheses being squared, right? That means it's multiplied by itself. Okay. So that means it's 2 times 3 plus z times 3 plus z minus 3 times 3 plus z and then plus 1. Okay. Now let's multiply these 2 out. I'm still not multiplying the 2. I'm only doing the 2 pairs of parentheses here. So 3 times 3 is what? 9. 3 times z is 3z. Now z times the 3 is another 3z. And then z times z is z squared. Close the parentheses. Minus negative 3 times 3 is 9. Negative 9. Negative 3 times z is negative 3z. And then plus the 1. Okay. Now I'm multiplying the 2 inside. And while I'm at it, I'm going to add these 2. Because 3z and 3z is 6z, right? So 2 times 9 is 18. 2 times 6z is 12z. Okay? Times z squared is 2z squared. And I'm just going to copy this down. Negative 9, negative 3z, and plus 1. So far, so good? Okay. Let me do this. There. Okay. Now let's combine likes. So what do we have? You have 18, negative 9. So positive 18 and negative 9 give you a positive 9. Plus the 1, that's a positive 10, right? So I wrote that one down. Okay. Next we have 12z, and you have negative 3z right here. So I'm using 2 lines to point those out. Positive 12z minus 3z is positive 9z. And then last but not least, you have the 2z squared. If you give me this answer, you are correct. If you want to rearrange from the highest power to the lowest power, that's fine too. Do this. It's the same thing. Okay? Any questions? Okay. Let's move on. Now in the previous section, I covered the concept of intercepts, which from the idea or even the name, it's the point where the function intersects, or I should say the graph, intersects the x and y axis. So the x-intercept is where you have x 0. Y is always going to be 0. And for the y-intercept, you get the point 0, y. X is always going to be 0. Okay? Now, how do we apply the concept of functions to this? Well, since for the x-intercept, I'm saying that y is always 0, and since f of x equals y, right, then that means f of x equals 0. Correct? So when you're trying to find the x-intercept, whatever function I give you, just set it equal to 0 and solve. And the x you end up with as a result is the value for your x-intercept. Okay? Now what about the y-intercept? Well, for the y-intercept, x is 0. That means you're going to have f of 0. So you plug in 0 into the function and then find the answer, and that will be your y. Okay? Let me show you an example. Here's number 14. F of x equals x squared minus 4. All right? Now what is my x-intercept? Okay, so we said for the x-intercept, y is always 0. That means f of x itself is going to be 0. So this is my f of x. Yes and no, and I'll show you why. So this is your f of x, right? So it's x squared minus 4 equals 0. I set it equal to 0. Now, we solve, right? This one is easy to solve. Just grab the 4, move it to that side, it turns positive. You have x squared equals 4. Square root, x equals 2. That's where we were. Yes, but when you take the square root, don't ever forget to add positive or negative. There's another clue. It's x to the second power. When you have something in second power, you will end up with 2 solutions, not just one. 2 to positive 2 and negative 2. That's 2 answers. Do you remember when we talked about linear and I mentioned conditional, identity, and contradiction for the equations? And how I said if it's a conditional equation, you only have the one solution? Well, that's for linear. If you're dealing with quadratics, you're going to have 2 solutions. If you're dealing with cubics, you're going to have 3 solutions for the conditional. Right? It depends on the power of the function or equation at that point. So here, since we have x squared, you have 2 solutions. So that should be a clue to help you tell if you made a mistake or not. So if you're solving quadratic and you end up with only one answer, that should clue you in that you forgot something. Okay? Now, so I got x equals positive and negative 2. Am I done? Is that my answer? If you stop here, if you give me this, you're probably going to lose point if it's, solved by hand. And if the question is multiple choice, you'll end up losing the question completely. Why? Because when you are asked to find the x-intercept, you're supposed to give me a point. That means an ordered pair. So means the answer is actually this. These 2 points. That's your answer. Not just x equals. I need the 2 points. These are the x-intercepts, not that. This. I've seen this happen before, where people give me that, or, vice versa. Please don't do this. Just because you have 2 doesn't mean they need to go on the same point. Remember, for x-intercept, y is always 0. The answers you find are the x values only. Okay? Now, it is possible for you to have more than one x-intercept, as you can see, but you will always only have one y-intercept if it exists. So it could, not exist. But if it's there, it's only going to be the one. You won't have more than one y-intercept. Because if you do, that means that relation has more than, that has one x with 2 corresponding y values, which means it's not a function to begin with. Does that make sense? So if it's a function, you will only have one y-intercept, because y can't have another x. Okay. So let's find the y-intercept for this one. So y-intercept. Now for the y-intercept, we're going to have x equals 0. That means you're going to plug in the 0 instead of the x. So I'm finding f of 0. So which equals 0 squared minus 4, right? Right here, instead of the x, I plug in 0. 0 squared is still 0. 0 minus 4 is negative 4. That's the y. So my y-intercept is what? 0, negative 4. Again, you need to give me the pair. Okay? Let's do another one, right? So for this one, I'm going to change the letter so it won't be confusing. I'm using g of x. It's still a function of x, just a different letter. Okay. And this one is what? 3 minus the absolute value of x. Okay? Now I need to find x and y intercepts. Let's find y first. Y-intercept. This one should be fun. Okay, so for the y-intercept, I said that you need to find g of 0. Plug in 0 instead of the x. So that means 3 minus the absolute value of 0, which is still 0. So the answer is 3. So that means the point is 0, 3. Yes. Don't forget the parentheses. It's a point. All right, so that's your y-intercept. Okay, what about my x-intercept? Well, for this one, it's going to be g of x equals 0. That means you have 3 minus absolute value of x equaling 0. Now, if you remember what we said about solving absolute values, we said that you need to isolate it before you do anything else, right? So I'm just going to grab the whole thing and move it to the opposite side, since I need it to be positive anyway. So might as well move it and be done with that part. So you end up with 3 equaling the absolute value of x. So I remove the absolute value bars, and x equals what? 3. Is that right? Yes, positive and negative. Don't forget that. Here's a question. We don't have a root here. Why am I adding positive and negative? Well, if you remember, when we said removing the absolute value bars means you're going to set up everything inside the absolute value bar equals to the answer positive one time and negative the other time, right? And then you solve both. Well, in this case, the value inside the absolute value just happens to be x, so there's no solving needed. Just put it positive once and negative the other time. So we are already done. Make sense? Since there's nothing to do, that's your final answer. Positive and negative 3. So since I got 2 x values, which means I'm going to get 2 points. 3 and 0 and negative 3 and 0. Okay? So far, so good? Questions, you guys? No? Okay. Okay, here's a trick question. Well, actually, it's not a trick question, but more like a teeny tiny riddle. I like this one. I brought it on a test once. You have f of x is a function, right? So the question told you that f of x, a relation, is a function. And I didn't tell you what it is. So I'm not giving you the equation like here. I'm not giving you what it is. I'm just saying you have f of x and it's a function. So I'm already telling you it's a function. And then I said your x-intercept is the point 0, 0. What is your y-intercept? Can you tell me what that point is? I'll give you 30 seconds to think about it. Okay. Why do you say 0, 0? Well, think about it. He said the point is 0 and 0. Okay. Well, when it comes to y-intercepts, you know the x is always going to be 0. So this part we already know is going to be 0. But what is y? From the question, I told you that f of x is a function. And the rule of the function says that in order for it to be a function, each x value is supposed to have only one y value connected to it, right? Well, x is 0 for both. And over here, I already told you that x is connected to y0. If I have a different y value here, this is not a function. So the only way this point would keep this a function is if y was also 0, as in it's the exact same point. Now, is it possible for the x-intercept and the y-intercept to be the same point? Yes, if it's the point 0, 0, absolutely. Why? Because, I mean, if you think about it, let's try to actually use the back of that page. If you think about it really quick, you'll see that this is your x-axis, this is your y-axis, and the point 0, 0 is actually the intersection between the two axes, right? So if a function passes through here, the one point where it will intersect the y-axis is this one. And for x, it already intersected here as well. Make sense? So but just by looking at it, you'll be able to tell that it's intersecting both the x and y at the point 0. Which means that whenever you have the point 0, 0 as one of your intersects, you know is going to be in the other. Okay? So if it's your x, you know your y-intercept is going to be the point 0, 0. If the point 0, 0 is your y, you still need to solve this. Don't just assume it's 0, 0. Solve for it. But the only reason I'm telling you to do that is because sometimes you have more than one x-intercept. Like in the examples we saw, in both of them we had two x-intercepts, right? The fact that y is 0, 0 just guarantees that one of those two is going to be this point. Okay? So if one of them is 0, 0, you know 0, 0 is going to be in the other. Just in x's case, it's probably going to be more points. So just make sure you solve for those. But one of them is already going to be 0, 0. Did everybody get that? Any questions, you guys? Okay. Let's move on. All right, the next part, we're going to look at the idea of domains, right? So let's do that. I have the piece of paper printed from the notes. You can follow along here or on the notebook. It's up to you. But here we go. So for the first example, we have a quadratic. This is the graph of a function that has x to the second degree. Okay, this is a quadratic. So let's look at it. Now, we define the domain as the values of x and range as the values of y for the function, right? Okay. So you start at the negative. Now here's a hint that always helps. Look at the function. If the ends of the function are arrows and they're headed in a direction where they have a slant, even if it's a teeny tiny slant, you know that that end is going to infinity. All right? So for example, here, as far as the x is concerned, we're looking at the x-axis. Oops, I think it froze. Here's, oh, there you go. As far as the x is concerned, the lesser, or I should say, the smaller x gets, right? So we're moving in the direction of the negatives. The function is headed in that direction. So it's headed to negative infinity as far as x is concerned. So this goes from negative infinity. It's doing the same on the opposite side. So it goes all the way to positive infinity. So the domain here is negative infinity to positive infinity, right? Now, a quadratic function is a polynomial, right? It's a type of polynomial. So when it comes to polynomials, just keep in mind that their domain is always going to be negative infinity to positive infinity. The range does change depending on the function, but the domain will always be negative infinity to positive infinity if I give you a polynomial. Okay? Now, what is the range? Now, for the range, we're looking at y values. So you're going to look at the y-axis. Okay. Now, we start at the negatives. From negative infinity all the way to over here, y has no points. There's nothing here. The function is not defined in that area. Okay, so we're going to ignore those values. The first y value we're going to acknowledge is the one right here, the one the function actually touches, which is y equals 2. So at the point 2, right? Now, it keeps going all the way to positive infinity on two ends. So it's going to positive infinity. Now, do I use a bracket or parenthesis over here? It's going to be a bracket, yes, because we have a solid line. That means that that point is included. If it wasn't included, you would have had a hole, right? So since it wasn't disconnected, that means 2 is included. So it's a bracket. Now, I see, Louis, you said x bigger than 2. Yes, but not for x, for y. Yeah, so we're looking at the y-axis. So it's going to be 2 or above, which is what this is. All right? Yeah. Okay. Let's look at the next example. 18. Domain, x-axis, we're starting at the negatives. Here we go. We have an arrow headed in that direction. So that already guarantees it's going to go all the way to negative infinity. So that's where we're starting. That's the smallest value. Okay. So we move along up until this jump right here. One point is hollow, the other's filled in. And since one of them is filled in, that means you don't have a gap here. It's a function. And since one of them is filled in, that means we don't have a gap here. X still has an answer. So at x0, there is a corresponding y value at -1. Okay? So that means x0 is included in the domain still. Now we keep going, all the way to positive infinity. That means that this domain also goes from negative infinity to positive infinity. Okay? So as far as x is concerned, there is a value for every x in this line. Now, what about the range? Okay. Starting at the negatives, there's nothing below here. And the first value we see is at the point where the function touches right here, which is -10. So that's the smallest y value, and that's where we're starting. Since it's connected, solid line, that means it's a bracket. Okay, now we move up. At this point, we have 2 y values, 2 y values, 2 y values. The function is acknowledging every single y value from -10 all the way to positive infinity. The only place that might give you some doubt is this jump right here, right? Because they're disconnected. So this is -1. You have 0, 1, and 2 since it's hollow. those values seem to not have any y values. Now, but since you have the other side over here where it's going to infinity, so instead of like at 1 to -3 over here, where the y has two x values, over here at 0 it only has the 1, at 1 it only has the 1, at 2 it only has the 1, but it does have a value. Make sense? So it's going to go all the way to positive infinity. So sometimes I give you something like this just to confuse you, even though it's actually easier than that. Just make sure you pay attention to every single value as you move along the line. Okay? Now, let's do 19. Yes, that's right. Okay. So let's look at 19. For this one, again, x, we start at the negative. This is negative infinity. The function has an arrow, so it's going all the way to negative infinity. So that's where we're going to start, since that's the smallest possible number. All right. From negative infinity all the way to x equals 1, right here. Okay. Now, hollow, point. So at 1, we still have a value. Keep moving up until 4, right? So at 4, the function stops. This is a point, in case you haven't noticed. It's not an arrow. It's a point. That means it stops there. No more for the x. Okay. Now, since the point is filled in, this is a bracket. Okay. What about the range? Now, the range for this one is a little bit more tricky, so pay attention. For y, we're looking along the y-axis. From negative infinity for the y, all the way to 1. This is this line. It's y equals 1. Yes? So all the way to 1, there's nothing there. So the first number we see is 1. Now, after 1, there's a disconnect. See this gap right here? And there is no corresponding y values. Nothing touching there. It's a complete cutoff. So 1 is isolated, like this. You use squiggly brackets. No, it's included. 1 is included. Why? Because over here at x equals 1, we have x is 0. Sorry, at y equals 1, we have x is 0, and negative 1, and 2, and 3, and so on. So you do have values. Endlessly many, in fact. Yes? So it's included. So you put it in squiggly brackets, alone since it's disconnected. Nothing below, nothing above. And then you use union for this one, kind of like we used in inequalities, if you remember, right? So you use union, and then we start again at the point 2, y equals 2. So we go from 2 all the way to y equals 8, which is where it stops. And they both have brackets because both points are filled in. Did everybody get that one? Any questions? Come on, guys, don't be shy. All good? Should I give you a quiz? Yeah, I always do those in class. When no one says, it's like, okay, then that means you mastered it, right? You ready for a quiz? It's like, nope. Okay. How about this one? Can you guys do this one? Tell me what domain and range is. I'll give you 2 minutes. So what are we thinking here? Let's look at the domain. You have x starting at negative infinity. Nothing here all the way up until the point of 2. Negative 2 over here. That's the first point. So that's where we start. Negative 2. It's filled in. Quite big, I might add. So it's bracket. Okay. We're moving along the line. We have a function, we have a point, we have a point, we have a point. And it's going down, but at a curve. So it's going to keep going down, but the x value is going to keep increasing. So it goes all the way to positive infinity. Okay, that's your domain. Now what about the range? We're looking at the y values. Starting at negative infinity. Nothing here for the function. Nothing, 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 nothing. Up until right here, which is y equals what? Negative 1. Okay. However, if you notice this of the function, it has a downside arrow. That means it's going to keep going to negative infinity for the y. So make sure you notice both sides. So since this is an arrow pointing down, that means it's going to keep going down. It's going to pass negative 1. It's going to give you values for everything below. So it's actually negative infinity. Okay? So it starts at negative infinity because of that arrow. All right. Now let's keep going up. Up, 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 up. Stops right here. There's nothing above this. And this side's not an arrow. That one's going down. So this is the highest value for y. And it is 4. Since it's solid line, so it's a bracket. Any questions? Okay. So now I'm going to give you guys an exercise where we practice everything we just saw all at once. Okay? Here we go. This is example number 21 in the note set. Is everybody still with me? You're too quiet. Yeah? Okay, good. Great. Now, here's 21. I gave you a graph and I said that it's y equals f of x. So it's a function of x, but I didn't tell you the equation. I just gave you the graph. And I want you to answer all of these questions. A, what is f of negative 3? So without an equation, how will you be able to find f of negative 3? Well, I'm asking you to substitute negative 3 instead of x. That means the x value is what? Negative 3. I also give you the graph of the function. So let's go here. Look for negative 3, which is where? 1, 2, 3. Right here. Follow along the line until we encounter the function. And then follow along the y line until you find the y value corresponding to that, which is also negative 3. So the answer for this is negative 3. So what I did there? Okay. What about f of 0? Same thing. You go to the point 0 for x, and you look for the function. It's right here. At 2 for y, so the answer is 2. Right. Now, C is asking you to do the opposite. I'm telling you that f of x equals negative 1. Which means what? Which means y equals negative 1. Because f of x is y, right? So I'm saying f of x equals negative 1. What is the x value? So I gave you y, give me x. So we're going to do the opposite. You to the y-axis, you find negative 1. You follow it until you encounter the point, which is right here. And then you go up to the x, and it's negative 1. That's right. Okay. D, asking the same thing, only for y equals 1. So f of x is positive 1, which is right here. This is y at 1. That line. Well, this one might be a little bit more confusing. We have 2 possible points. Only one of them is what? It's hollow, right? It's at 1. Y doesn't have a value here. Only here. And this is, x is 2. So the answer is 2. So far so good? Oops. Okay. Now, E is asking for the x-intercept. Looking at the graph, where does the function intersect or at least touch the x-axis, which is the horizontal line? Nowhere, right? It doesn't. Which means there is no x-intercept. That was easy, right? Okay. What about the y-intercept? Where does it touch the y-axis? And remember, the answer should be a point. At 2, y equals 2. Since y is 2, x is 0, the answer is 0, 2. And if you notice, we kind of already answered this one when we did B, because you found f of 0, right? That's how we find the y-intercept. Okay. Now, what about G? It's asking you to find the domain. I'll write it right here. So I won't have to scroll up the paper too much and you'd see the function. So, domain of the function. Starting at the negative end, it's going to negative infinity. So, negative infinity. We're moving along up until here. You have a jump. One of them is filled in, so we're still good. Keep going, keep going, keep going, all the way to positive infinity. So, it's negative infinity to positive infinity. What about the range? Why am I writing it down? Anyway, so for this one, we're looking at the y. Again, it's going all the way to negative infinity. So start at negative infinity, go all the way to negative 1, right? This line right here. And then we're going to have a cutoff, because as you can see, there's nothing of the function in this area, right? We don't have a single y value there. So for y equals 0, there's nothing. Y equals negative half, positive half, everything in between right here. All these y values, there's nothing there. There's no function. So it cuts off at negative 1, and then comma. Sorry, a bracket, because this point is filled in at negative 1. Union, and it starts again at 1. So we have 1, and it goes all the way to positive infinity. Now here's the question. In front of the 1, is it a bracket or a parenthesis? I'll give you a minute to think about it. It's a bracket, that's right. 1 is a bracket, not a parenthesis. Because you looked here, right? This is the y equal 1, and it's hollow, so you thought parenthesis. But notice question D, where I already asked you about it. F of x equals 1. And we said 2. There's 2 points at 1 is 1. One of them is hollow, the other is not. Since one of them isn't, that means this is going to be a bracket. Now, if this dip didn't touch 1, or was like ended at 2 and went up there, or just never happened, then it would have been a parenthesis. But since it's there and it's touching y1, that means that value is included in the range. So it's a bracket. All right? Any questions? No? Okay. You do have a question? What is it? I think I have the option for you to turn on the mics if you want.
Can you hear me?
Yeah.
So if if the graph isn't really just a great picture and the point is just barely floating above or barely floating below, is that just at your discretion, or what do we do about that?
Okay, so I guess what you're asking is because the blue line here is like teeny tiny bit above the line. Is that what you're asking?
Yes, ma'am.
Yeah,
It's just if
yeah,
it's close.
that's probably an error in the graph. So if I give you a graph that has something like this, just assume it is connected, right? Because I won't give you something that requires you to pay that much attention to the piece of paper. Make sense? So if yeah, looking at it from afar should be enough for you to be able to tell. So if it's like teeny tiny bit above, yeah, don't worry about it. Okay? So I'm not requiring you to think of decimals. Like this is fraction above. That means that's 1.0001 instead of 1, you know? Don't worry about that. It's never gonna be that gnarly. Maybe on the homework, but not on my questions. But yeah. Any other questions? Does anybody have any questions about the test or the homework? If not, you may leave. We're done. All right, you guys, have a good evening.